Hey you guys, Ms. Smith here. Today we're going to be talking about graphing exponential story problems with tables. Okay, so we're going to work on problems number 1 and 2 in this video. Feel free to fast forward or rewind, however it helps you best. Let's read problem number 1. Rentals in a high-rise apartment building get more expensive higher up since the views get better. The ground floor, floor 0, rent is $1,900. The rent increases 3% per floor. What is the rent on the 8th floor? Okay, so we're going to make a table, but first of all, let's make sure we know how to write our equations for these kinds of problems. We did this earlier in the year, but it's been a minute, so let's review. We've got these two equations, one for growth and one for decay. So in the growth problem, you'll notice it has a plus, and in the decay problem, you're going to notice it has a minus, which makes sense because growth means we're getting bigger, whereas decay means we're getting smaller. The A stands for the initial amount, for the amount you're starting with. The R stands for the rate, and the T stands for the time. So let's take a look at our problem. First of all, is it growth or decay? Well, let's see. It says the rent increases, so I'm thinking that this guy is going to be a growth problem. So we're going to use this equation right here. Now let's figure out our A, our R, and our T so we can write our equation. So the A is going to be the amount that we're starting with. The amount. Well, it looks like we're starting with $1,900. And so we're going to put A equals that. A equals 1900. Okay, let's look for our R. R stands for rate, and it's usually going to be a percent. Very often a percent. And I see a percent right here. Now we want to write it as a regular number. So how do you write 3% as a decimal? Well, maybe you know that you just need to move the decimal 2 places, and so you get 0.03. But if that ever mixes you up, you can always take the percent you're given, like 3, and just divide it by 100. Percent literally means per 100. So you can always do that to double check yourself if you're unsure. Okay, and now we've got our T, T for time. Well, you know what? It's not really time in this case. In this case, it's the 8th floor. So like think about you're going up the stairs 8 times, and each time you're going up a level, it's getting more expensive. So for time, we're going to do 8. Okay. And now let's make our table. It looks like we are, now what we really want to answer this question is just the amount on the 8th floor. But we are going to actually find out 0 through 8 so we can make a nice graph as well. So anyways, like I said, back to our equation. Remember, y equals a parentheses 1 plus r to the t. So I'm going to write down here our equation with those values filled in. So instead of a, I'm going to write 1900. And then I've got my parentheses 1 plus, now let's see, what was r? Oh yeah, 0.03. Close those parentheses up because that's what it does in the equation. And then we've got our little exponent of t, and t is going to be 8. So I'll put my 8 right there. Okay, now like I said, we want to figure out the 8th floor, so we're going to make a table, 0 through 8. Actually, we don't need 0. Well, I'll put it on the table for fun, but we know that at 0 it's 1900, okay? It's always good to start those exponential tables with a 0 in the top left corner. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Now again, mathematically, you don't have to do all 8 to figure out just what the 8th is. In fact, let's start with the 8th just for fun. But we do need to do all 8 floors for this problem because we want to show a nice graph with a curve and everything like that. Nice curved exponential equation graph. So just for fun, we're starting with the 8th floor because I feel like it. Let's take our equation. Now you don't need to try to put y equals in that calculator. Just start with your 1900. And then you've got your parentheses. 1 plus 0.03. And if you don't have access to one of these calculators, I'm going to show you on my phone in just a second, so stay tuned. Close in the parentheses, and then we need an exponent, so do your x to the box button. And that exponent's going to be 8. Double check, make sure it looks right, and then you can hit enter. And it looks like the rent on that 8th floor is going to be $2,406, and let's round to the nearest hundredth because dollars and cents, 86 cents. 2406.86. Okay, great. Now, where do we want to go next? You want to just do the whole thing backwards? You could definitely work up this way or back that way, however you want to do it. The next one I'm going to show you is going to be on my phone, as promised. You're going to go to Desmo's scientific calculator, not the graphing calculator. I'm just going to show you the scientific calculator because it's most similar to this and very useful for making your table. I'll just go ahead and pop down to number 1 here. And again, I'm going to not put the y equals in. I'm just going to start with 1900. And then you've got parentheses opening up, 1 plus 0.03, and then closing those parentheses and doing the exponent of 8. And for the exponent, you're going to hit this button that looks like a to the power of b. That's what you want. And 8, and then whoa, look at that. I think I did something wrong. What did I do wrong? Oh, look, I put a times instead of a plus. This is definitely not the answer I'm looking for, so let me go back and change that. And I hit enter instead. Let me try again. Plus 1 plus 0.03. Oh, no, that's looking a little bit more reasonable, isn't it? Okay, 1900 times 1 plus 0.03 to the power of 8. And I put an 8 in. Why did I put an 8 in? That should be a T. You guys, I am so sorry. I was thinking about figuring out the 8th floor, but I wasn't thinking about the fact that we were making a whole table, okay? So if you're going to make a whole table, you don't really want to put this in the equation. You could just leave it as T. You could even change it to an F for floor if you wanted to, but this is the number that's going to need to change every time you change your floor, so I'm just going to leave it as a T in my equation. Now let's go back and see if we can get a better answer for this. So instead of instead of 8, I'm going to put in 1 for first floor. That looks right. 1,957. 1957. Okay. Now, the cool thing about using Desmo's scientific calculator is, do I need to type in this whole equation again each time when I'm going to just change the exponent and nothing else? No. Can I just hit the backspace button? And I'm going to make it a 2. Look at that. 2015, 71. I'm feeling so good about this right now. So I'm going to now make it a 3. 2076.18. Okay, make it a 4. 2138.47. 2138.47. Okay, make it a 5. 2202.62. Couple more left, make it a 6. 2268.699 is going to bump up to 0.70. So 2268.70. And then make it a 7, and we get 2336.76. Okay. Our table is made. Let's put the calculator aside. Now we get to do the fun part, which is always making the graph. Can we see this all? It kind of fits. I will start with just the top of the graph. So the x value of 0 is going to be here on the graph. Looks like our y value is 1900. So I'll start here and I'll go up to 1900, which, let's see, how are we counting? 1600, 2000, halfway between that would be 1800. So it looks like we're counting by 200, so like 200, 400, 600, 800, etc., etc. So here's 1800, here's going to be 1900 right there. Okay, next one. 1 comma 1957. 1. I don't know if we're going to be able to even see a difference at all. I'm going to put the dot pretty much in the same place. Second floor, 2015. So 2, that's going to be above the 2000 mark, but not by much. And then for 3, we need 2076. 2076 is going to be above 2000. And let's see, this is 2200, so it's going to be maybe like right here. And then we've got 2138. So again, this is 2200, so it's going to be more than halfway there, and then maybe like right here. This is not a perfect graph, but we're just going to keep going. 5 is 2202. We can be pretty precise with that. We're just going to put it right at 2200. And then 2268. 2268 will be about a fourth of the way there. 2336, we got 2300 right here. I'll put it just barely above. And then we've got 2406 for my 800, for my 8, 2406. It does look a little bumpy. This one especially looks like it's sticking out. So let me just see if maybe I did something wrong. Let's see. 2015, maybe I just kind of put it a little too high. Maybe a little lower for that and maybe a little higher for this one. And then it kind of smooths out. And we're doing a lot of estimation here, so it's not a big deal if it's a little bit bumpy. Okay, there we go. There's our graph. That's all you have to do for problem number 1. I'm going to also show you problem number 2, which uses the other formula. Make sure you're always choosing the correct formula, otherwise all that work is for nothing. We don't want that. Problem number 2, a robot vacuum cleans a dirty floor using multiple passes. During each pass, 23% of the dirt is removed. If the floor initially has 410 milliliters of dirt, how much dirt will remain after 7 passes? Okay, so this is the formula that I want to use. And the reason we're using decay is because the amount of dirt is decreasing each time. And when it's decreasing, we want to use the decay formula. What is our initial amount? Let's see. Initial amount, not 23%. Oh, it looks like it's going to be 410 milliliters. So just I'll write 410. And then what's my rate? It's going to be, usually it's a percent, looks like 23%. So remember, we need to turn that into a decimal. I'm going to move my decimal 2 places. It's going to be 0.23. But remember the special trick, if you want to use it, it would be to take that percentage and divide it by 100, and that will do it for you. And then finally, we're going to do the same thing as last time. We're just going to leave the t as a t. And we're going to know that we need to get our table all the way up to 7. Okay? So let me make my table. 0, 1, 2, 3, 4, 5, 6, 7. And then let's go ahead and build our formula. I'll just say t equals t. How about that? Since we want multiple values for that. Okay, y equals, our initial amount is 410. Parentheses, 1, and this time we have a minus because it's getting smaller. It's getting less and less dirt. And the rate is 0.23, and then we'll leave the t as t. Okay, now we don't really need to solve for 0 because that's just our starting point. That's our initial amount. So for 0, we can just say 410. But we do need to solve the equation to get our amount for line 1. I'm going to use this calculator, and then I'm going to switch to the other one just because it went so nice and fast, and I loved that. So we're going to put 410 in first, and then times parentheses 1 minus 0.23. And then my exponent is going to be the x value, which is going to be 1. Whoops, I forgot to hit the exponent button. X to the box, and then 1. Okay, 315.7. There we go. Now, is there an easy way to go up here and just change it? And well, if there is, I haven't figured it out. So I'm going to switch to my phone with that wonderful Desmos Scientific Calculator. And let me just delete all of that. And I'll put in the new equation, 410. Now, on your test, of course, this is not going to be available to you because you can't have your phones out or your computers out during your test. So you will have to redo it with the calculator on the test, okay? But it's okay to do it the easy way for right now because it doesn't bother anybody. So I'm just putting in my equation, and then my exponent that I want to use is a 2. Let me get those lights turned back on. So I'm going to hit my A to the B button, and then 2. And then my answer is showing up right here, 243.1. When you round it, those lights turn back on. There we go. Can you see that on my screen? That's what it looks like. Okay, and now I'm just going to go back and delete the 2 and put in a 3. And we've got 187 point, let's round that to 2. And let's put in a 4. 144.1. Let's put in a 5. 110.0. Well, that's going to bump up to 111.0. And let's put in a 6. 85.5. And let's put in that 7, so 65.8. Okay, so how much dirt will remain after 7 passes? 65.8. Let's go ahead and put this on the graph. So at 0, you have 410. 0, 410 is going to be right about there. At 1, you have 315. Right there-ish. 2, 243. I'm going to go, let's see. 240 is going to be right about here. I'll put it there. 3, 187. So here's 175. There's 187. And again, estimating is totally fine here. 4 is 144. It's pretty close up here to 150. 5 is 111, just barely above the 100. 6 is 85.5, which is going to go about right there. And 7 is going to be 65.8, which is going to go right about there. Okay, and then connect your curve. And that's all you got to do. If you have any questions, feel free to ask your teachers. We love getting your questions. We love helping you with your questions and getting you answers. And otherwise, I hope you have a great day.